screen?
Yes.
Okay. All right. Hey guys. Good morning. My name is Paul Kavasag, and I am doing mine's my final project on real estate property valuation. And yeah, this is kind of similar to how Zillow does it, but it's very skeletal. I did run into some issues, but I did what I can. So for just to remind or recall what I did for problem description, mainly the gist of it is to get a predicted like dollar amount, dollar valuation for either listing or sales price. And just to it does say objectives one, two, three, but it's just kind of like a sequence of what I did. So I took a look at mainly the valuation, like getting the price automatically, and I did mention before I was going to compare this to a manual way of looking at the sales price, but I didn't have enough time to do that. So and then plus it wasn't really related to like what we're doing here. So I kind of just cut that off and just use machine learning price. And there was two sets there, the 2016 and 2017 for property prices. They're very similar. So that's like one of the reasons it was really easy to implement it because then you just you just read a different like data set. And the main feature here is to look at the performance, and the metrics I used were, I think it was like four, but the module here was like linear regression and then gradient boosting tree regression. Okay, so yeah, same the data source was the housing data. For exploratory data analysis, I did take a look at, so here, this is high level, then I'll talk about it specifically in the next slides. So there were like 58 features, and this is a combination of like Boolean strings and numerical features. For this basic like machine learning product, I wouldn't really omit strings and Boolean. I would go ahead and maybe do like one code encoding or one high encoding, but I ended up doing that. I just omitted those for my feature extraction. I think it would affect the Boolean will definitely affect my result, but I didn't test that. And then for the null values, what I ended up using was I did replace those with the mean of like the feature columns of that column. And then for the metrics, I use root mean squared, coefficient of variation, and then mean squared error, and then mean absolute error. And I did change my feature, my response feature of target variable. Instead of using like separately the structure value and then the land value, and then do the regression twice, I did found that one of the features was actually just the addition of those or the sum of those, which is the tax value here. So I just used that, so it would just be one run. And for the modules, the main thing here that I used was PySpark, MLlib, and the two packages was the linear regression and then the GBT regressor. Okay, so mainly here I'll just talk about each of the procedure and explain why. So for linear regression LR, I obviously imported the libraries here, and then from there I started with Docker first, so that's why I had this initialized Spark, and then after that, and I would read the data. So as I said, I would read it from 2016 and 2017 here. And then I would do the feature selection, feature extraction next. So I would look at what columns or features I would have. And then from there, I would look at, I would summarize and see, okay, do I have any variables or strings or Boolean numerical variables? And then I did take, so these are the ones that I wanted to drop. Number of hot tub, property, county, land, and then this flag is just a flag, which I think is like a Boolean. And then the zoning description, I think, and that's another Boolean. So these ones, since I couldn't really, run it without like changing this to numerical values, I just dropped them in this first pass. So, and then with that, I wanted to replace the null values as well. And then so in here, what I ended up doing was I wrote this function to fill in the mean. I think there's like different ways of doing it. I could have just used that imputer, I think, which is like built in, but I just used this function instead, which it takes in the data set and then it automatically just replaces the one that I had with the mean of that column. Okay, so after that, this is where I kind of based it off what we did, I think, for like assignment 3, which is coincidental. So for vector assembler, this is where I I built the feature vector for each of the data set here, and then from here I would do the split for training and testing, and I just did the regular 75-25. I didn't end up going to test like whether it would affect my metrics, but I just used that. For C, just generalized it. I just used the typical 42 that we'd use. And for this next one, I end up using standard scalar as well, so it doesn't affect the data. And from there, I would transform using the scalar, the training and testing. And then, so that's just how you do that. From here, finally, I would use the linear regression and use this. I did end up using this the regularization hyperparameters, elastic net and reg param, which is from what I got from the assignment. I did use the second one, 0.3 and 0.5, because it gave like better results. Then for linear regression, you would get the coefficients and the intercept values, obviously, there for each one of the 2016 and 2017. And then I did check the training and then testing results just to check for overfitting. The training results, I had the RMSE, the coefficient variation, and then MSE and MAE. And lastly, I ran the prediction, so using the regression evaluator for PySpark. And in here, very similar, I would like use this evaluator to get the prediction, and then use the here, and then I would use these different metrics just to get each one for the testing model. So for the other module, the gradient boosting tree regression, everything is very similar except for the part where I do the regression. So what I did here, and I think I'll explain why I use GBT. So initially, what I wanted to do here was to use GBT to compare it to LR, so that I would see if any of the accuracies are changed, and whether, because as I've learned, GBT is good for like a very homogeneous data set. And for this, there were a lot of unrelated data, like futures. And the one thing I realized when I was using GBT was it had to use a lot of hyper tuning. And then once I ran like just the same amount of like max iterations, I actually didn't get as good of a result as I wanted, and it was taking a while. So I guess in terms of later purposes, I would probably tune it to like maybe more iterations, and for GBT, there's also some. I'll talk about it in a bit, but once you run it many times for like max depth, and as well as like a learning rate, which you can incorporate in GBT, you could increase the accuracy. So here I just took the basic path, so same number of iterations as I did for the LR. And then I tested the model. I didn't check for the training. I couldn't figure out if there were any, if there were already any functions that I can use in this GBT regressor to actually get some of the training metrics. So, but I just tested the metrics for the testing or for the prediction. So with that, looking at like some of the LR and GBT procedure, I did get some results. So one of the things another difficulty that I had was trying to graph. My intent was to actually graph, give you some graphs to compare linear regression and GBT. But when I tried to do matplotlib in AWS, it wasn't letting me. It said that it couldn't find matplotlib. But then that was already too late for me to do something else. And then I did try to use Google Colab and then the other ones, but it was giving me like it was taking a long time to load in the thing is like 1 gig file on both of these data sets, so it's pretty huge. So I just used numerical metrics, which was the intent anyways, but it wasn't the full intent. So for linear regression, surprisingly, it was already good. The coefficient of variation was like 0.97. So, and then I also had, for this one, compared to the GBT, it had a higher RMSE, MSE, and MAA. For the GBT, so after doing some, it took a while to hypertune it. So like you could actually hypertune it by increasing the depth of the tree, or the number of iterations, and the learning rate. You could reduce that, but that meant it would also increase the computation time. So I did that for a while, and then I did get some results. So it was greater than the linear regression, and all the error metrics here were lower. And with both of these, the other thing is the comparing 2016 and 2017. I didn't include it here, but the 2017 actually had a higher coefficient of variation. So I guess that meant that it did better in the prediction because then for that. Okay, so for conclusions and insights, linear regression, I had a faster training and testing time. It was really quick. It was like it didn't even load for linear regression. For gradient boosting, however, it had a slower training time and testing time. And when I meant this, I wanted to actually probably track the computation. I didn't have time, but this is more like a conceptual, just looking at how long it loaded. And the second point here, so linear regression, I optimized it, as you saw, with this hyperparameters, number of iterations, regulate the regulation parameter, and then elastic net parameter. And then for gradient boosting, I also optimized that. I think I need to do that more just to confirm if what I have is correct. So, but for those, that would mean I would use like number of iterations again, and then the tree depth, and then learning rate. I would reduce that and increase the depth. Okay, and then I didn't include a slide for challenges, but I did experience a lot of that. So for different ways, I think it was just trying to use or trying to get a good value for the gradient boosting. I ended up using AWS EMR by increasing the amount of cores to hopefully not take too long. But then another thing is also graphing. So I wanted to compare some like graphs, but AWS EMR, it didn't allow me to do Matplotlib. And for future work, I would say, yeah, I would use what I have here, and maybe two. Okay, and then for GBT, as I said, it does overfit. So maybe use another type of regressor, just so that it's easier, and then confirm what I have for GBT, because it may not be the right answer. So for linear regression, I felt like that was already good, but just for future work, just to look at different types of regressors and check the computation time by actually inputting it, not just looking at it conceptually. Okay, and this is all my references, and do you guys have any questions?